either positively or negatively. Now, how do we charge an electroscope by induction? What is the meaning of induction? To induce. Now, in order to charge an electroscope or any other object by conduction, what we did is we placed the charged object in contact with the neutral conductor. Now, in charging an object by induction, you don't make the charged object in contact with the neutral conductor. You bring it near the neutral conductor. Do not make contact. You see, what happens? Let's talk about it. Now, bring a positively charged object close to an electroscope platform. What happens? Here is a positively charged object. You bring it to the platform of an electroscope. What happens is, you see, because of the presence of the positive charge, the negative charges from all over this conducting body. Look at this, the leaves, the stem and the platform are all conducting. So all the free electrons will be drawn to the top of the electroscope, leaving the leaves positively charged. That means the moment you bring a charged object near the electroscope, you will see a divergence. Why? Because of the presence of these positive charges, a lot of negative charges moved to the platform because of their desire to be closer to this positive charge. That means a lot of negative charges were moved from the leaves, leaving the leaves positively charged, and that produces the divergence layer. Because the presence of a positive charge very close to it, negative charges from the stem and the leaves of the electroscope move to the platform, leaving an excess positive charge in the leaves. Now, this process is called polarization. What does polarization mean? Polarization is a split. Have you ever heard of polarization in a political party? Yes. A split of ideas in a political party is referred to as polarization. The split of electric charges in a conductor is called polarization. And what is the cause of this polarization? The presence of this charged object. Now, the leaves diverge due to the presence of this excess positive charge. Alright, this is step 1 of charging an electroscope by induction. So what is step 1? Bring a charged object. In this case, we are using a positively charged object. Bring a positively charged object near the electroscope. Now, the negative charges get drawn to the platform, leaving the leaves positively charged. You see the leaves diverge. The second step is ground the conductor, ground the electroscope by touching. If you now touch the electroscope, what happens is, because of these positive charges, a lot of negative charges will now move from the earth, will come and neutralize those positive charges. That will cause the leaves to collapse. And now that means you have removed some excess positive charges from this neutral conductor. And now remove the grounding. What happens? Those positive charges which were on the leaves are no longer there. They are removed because of the grounding. That means the electroscope now has some excess charge. And now if you remove the charged object, the electroscope will retain those negative charges. And this is how you charge an electroscope by induction. Alright, now here I have the various steps of that. Now look at this, bring the charge. Here I have got a negatively charged object brought near this is the neutral conductor. and I'm going to bring a negatively charged object close to it. Alright, let's start from the beginning. We start with a neutral conductor. There is one. The neutral conductor, bring a negatively charged object close to it. What do you call this? Polarization. You see, the negative charges all now go to the earth. You ground the neutral conductor. Now, there is an excess amount of positive charge in the neutral conductor. When the charged object is removed, the neutral conductor retains a net positive charge. You see, in my earlier explanation, I used a positive charge. In here, we use a negative charge. Look at polarization. Negative charges move away, and when you ground it, those negative charges move to the earth, leaving a net amount of positive charge in the conductor. Alright, now let me see if I can illustrate that over here. I want to charge this neutral electroscope by induction by using this negatively charged object. What's the first step? Bring the negatively charged object near the electroscope. You see, I haven't touched it, but look at the leaves diverging. Why? Because all the negative charges are drawn to the sphere, leaving the leaves positively charged. Now what happens when I ground it? Now keeping the charged object there, I ground it. That means all those positive charges in the leaves have gone to the ground. Now remove the grounding and remove the charged object. Well, apparently I grounded it again, but the electroscope now has some excess negative charge. Now this is the process of charging by induction. Charging by induction. And you must be familiar with the various process of charging by induction. You can see, bring the charged object near the neutral conductor, ground the neutral conductor, remove the grounding, and remove the charged object. These are the steps for charging by induction.